Good afternoon, everyone, and welcome to this webinar on generative AI, which is part of the Climate Action Beacon's 2024 webinar series. Let me begin by acknowledging the Yugarabal, Yugera, Jagira, Turrbal, Yugambeh, Kumanberry peoples, who are the traditional custodian owners of those lands on whose lands the 5 Griffith University campuses are located, and I pay my respect to the elders past, present and emerging. I'm delighted to be able to introduce you to today our presenter, Professor Bela Stantic, who's the Professor of Computer and Data Science in Griffith School of Information Communication Technology and Director of the Big Data and Smart Analytics Lab. Before I hand over to Bela, I just want to say that disinformation on climate change is a growing problem. It's feeding climate deniers, those with a vested interest in business as usual, and seeding confusion amongst concerned and interested citizens. With the now widely available public access to generative AI, the issue of trusted information becomes absolutely central to the integrity of public debate on the climate crisis and the urgent need for climate action. So in that context, Professor Stantic is talking to us today on how we can harness generative AI and fine-tune large language models to help us better inform and empower the right kind of climate action that we need. So without further ado, over to you, Professor Stantic.
Thank you. It is my great pleasure to present today's webinar, Empowering Climate Action, Harnessing Generative AI, Fine-Tune Large Language Model. So what I will present today, at first, I will talk a bit about traditional, what we did, and at first, and I will eventually talk how we actually used these features, ever-advancing feature in AI, explosion of generative AI, and how we harnessed large language model by fine-tuning with the climate action relevant documents. So before I start my talk, I probably put some additional information to you. I'm dubbed in media as a Nostradamus of 21st century because of all bold and correct predictions of elections and everything. But I obviously don't have a crystal ball. But what do I have? It's a vast amount of data, immense computing power, and know-how. So why is this important to say? Because everything what we do in relation to climate change, all these algorithms have been tested for their accuracy for topic, sentiment, and everything. So it gives us high confidence that information that we extract about the climate change from public information have a very high accuracy, considering that same algorithms methods are used on this election prediction, and I predicted everything with a decimal point accuracy. I would also like to mention, because I'm quite proud that I and my Big Data Lab are named the Public Health Champion for our help during the pandemic for all levels of government. I'm sure that not very often computer and data scientists are named Public Health Champion. So methods that I will showcase you today, what we do with artificial intelligence, large language model, generative AI, we applied as part of my Big Data Lab to many projects, and as you can see, to many domains. We also applied in environment specifically as well to the climate action as part of the Climate Action Beacon project. And the core of this talk obviously will be related to this topic. At first, I will talk about how we extract the opinion from public, but the main part is actually what we have done regarding the fine-tuning large language model with the specific documents related from the IPCC reports, and to ensure that people can get consolidated, trusted information from these reports. But I will also demonstrate DORIS, Generative AI, fine-tuned climate action beacon, which is running locally on the big data cluster at the Griffith University. I have recorded some videos because at present I'm in Hong Kong, so it's not easy for me to connect live to big data clusters. And what I would like also to mention that last night I returned from China, where was the United Nations conference, Asia Pacific, related to tourism, where I talked about how to utilize AI to get opinion, what tourists want, do the predictions, and in general their opinion. But why I'm saying this, because part of these talks was also how climate action, how climate changes influence the tourism, and what action tourism people need to do. So it's obviously climate action is entering the many areas. So we have artificial intelligence is harnessed in many aspects for the climate change, of course, in form of short and long-term climate modeling, predicting the weather patterns, temperature changes, disaster responses. My team also in past looked into social media in a disaster area to monitor how people are moving, what is their demand. So we can use the AI to optimize energy use. Yeah, we can also improve the traffic flow and logistic. If you can recall from list of my projects as well, I had a project which enhances the optimizes actually traffic. Definitely, there is a lot of values what AI can do in relation to renewable energies, to improve the efficiency of these sources of wind and solar. There are aspects of modeling for carbon capture by optimal identifying optimal location, monitoring deforestation, and obviously there is a lot of areas where AI can help in agriculture as well. So I believe that I just listed some of them. Many of you are experts in this area. So I'm sure that you know many more than I have listed. I just wanted to showcase that AI is present already in many forms and regarding the climate change. The importance of the climate change has been recognized at Griffith University by forming the Climate Action Beacon, and Professor Brendan Mackay, who just introduced me, is the director of the Climate Action Beacon. So to use the AI for anything, including for climate action, you must have extremely powerful computers. So if you don't have $1 billion to buy a Cray supercomputer, the more recent approach is to have a computing clusters. At present, the most powerful computing cluster is Frontier, which has 1700 petaflops. For those who don't know what is petaflop, because obviously despite being a computer and data scientist, I sometimes lose actually track the tera, giga, peta, exa, what it is. But petaflop means 1,000 million mathematical, decimal point mathematical operations per second. So it's obviously incredible number of computation possible with 1 petaflop. And this is necessary, particularly when we work with image or video processing or with this deep neural network generative AI. These are some of the computing clusters that we have at Griffith University and my big data and smart analytics lab rely on. We obviously don't have a frontier, but it's a significant power, which is recently enhanced with the graphical processing units. This year in August, we have another node with 8 and these graphical processing units, and where each graphic processing unit has almost 7,000 or H100 has more than 14,000 CUDA cores. So the normal computer usually has about 4, more powerful has 8 cores. But what's important that a single unit has about 1.5 petaflops. And what I will demonstrate you, it runs on these units. So how we can harness AI for computational advances? A lot of methods that we use, we haven't yet published yet. But obviously there is a lot of pre-trained transformers to reduce the need for annotation of a deep neural network, to training data for deep neural network. We do a lot of fine-tuning of large language model. You will see, I will showcase, we have our large language model. We have also generative AI called the DORIS, Digital Oracle for Research in Sciences, which is the front end accessing these fine-tuned large language models. In this case, I will showcase you the model which is fine-tuned based on IPCC reports. In addition, it's still a lot of other machine and deep learning, particularly when we work with images convolutional neural network. In the traditional data mining, still there is need to have a clustering. And in addition, this natural language processing, such as sentiment, emotion analysis, topic modeling, which are crucial if you want to assess public opinion. What is important that everything can be done and has been done in a near real time on real data, as you will see as well dashboard for opinion from Australian public toward the climate change, which is live, and it's refreshing. I think at the moment we have a weekly, but during the COP conferences we did refresh a daily specific dashboards for COP conferences. So these are some of the methods where we started before. We applied methods to tourism, where we identify where from are people coming, what is their opinion, what sentiment, what they like, what they didn't like. Based on their trajectory and locations, we identify are domestic, are international tourists. And based on clustering, we could find out how many people were at this day, at what location during what time, and what was the percentage of change. Why it's important to mention, because these methods provide the near real time actual data, in contrast to any statistical data which are usually a year old. That it can, these analysis and the findings can be used to have a proactive actions. So this is the near real-time sentiment emotion analysis and topic modeling of social media posted from Australia relevant to climate change. Members of the Climate Action Beacon, including Professor Mackay, we identified the key term topics, and my team and I build up in a background these methods which are analyzing what are actually topics, what is sentiment, what's emotion, where from are people talking. We even could identify as well the age of the people who are posting, because in a metadata of description of profile of user, people tend to say happily retired, lawyer with 10 years experience, studying something, and from these, after annotation, we train the neural networks, and with about 80% accuracy can predict the age of the people. So that I provided you a link on this page, but you can Google it. If you Google Climate Action Beacon, it will, and follow the links from the main page, you will navigate. Why it's important? Because you can do different type of filters and different pages where you can see the sentiment, spatial, topic, even comments provided. As you can see here, specifically this year, from 1st of January 2024 to 7th of October, when I was preparing this slide, what is the distribution and what topics people are talking and what is their sentiment. But you can navigate through other pages as well. For comparison, I put the filter up to the 1st of January 2024 and from 1st of January 2024, and I saw that there is a different topics that start to dominate. For example, climate policy starts to dominate from this year, in contrast to previous, when was the second one. Other topic is a topic which deep neural networks could not associate with any of, we had about 20 different topics, but about 10 are the most dominant in a discussion. So if none of these 20 could be associated, because in some case post was aligned with the terms that we identified as the key terms for the climate change. However, none of the topics could be associated. In that case, the system assigned to others. So that was related to traditional methods where we use the natural language processing and the topic modeling, sentiment, emotion analysis, spatial analysis, semantic networks, and created dashboards. However, recent advances in pre-trained transformers and also in generative AI, particularly after November 2022, when ChatGPT 3.0 was released, enabled that we can ask in English sentence questions deep neural networks, these pre-trained transformers, which are trained on the specific content. And rather than looking into, for example, what are the dominant topics since January on these dashboards, we can ask in English question and received very accurate feedback. So we have taken that approach as a next step after having this dashboard, and particularly we relied on the trusted information. So we use the base model, as I will show you in a minute, and fine-tune it with trusted information. A last fine-tuning I have done on 29th of May this year, because from June I'm on move. At present I'm in Hong Kong. The second part of year I'm on sabbatical, and I'm visiting quite a few universities and collaborate with them. So this fine-tuned model that we have, it has 14 billion parameters, but I will demonstrate how accurate and how good it is. In many aspects, much better than ChatGPT, because it relies on the trusted information and not contradictory information. Yeah. So our model has 14 billion. ChatGPT 3.5 has 175 billion, and according to some sources. And for ChatGPT 4, it's undisclosed. However, there is some indication there is 17 billion, 100 billion parameters. Why is this important to mention? Because these huge models require extremely powerful computing power. This our model theoretically can run even on our mobiles. And in one publication that we published in 2021, we showcased that smaller models, base model fine-tune ensures the high accuracy. So how we fine-tune these models, it's basically we use the low-rank adaptation or LoRa, where it is possible to decompose large neural network into low-rank approximation. So as you can see in red, by using this decomposition of weights, 100 million parameters can be decomposed in 200,000 parameters. Why is that important? Because thanks to this approach, we are able to train the model much faster and requires less computing power. ChatGPT required 20,000 A100 GPUs. Do you remember we had 8 only? And it was training it since 2021. So it first cost extreme long time, but it also requires a lot of money to run these computers, not just to train, but it also requires later to run the systems. So this concept on the left-hand side, you see data selection and pre-processing. I will show you some steps, what data we selected, how we pre-process, and then we perform the fine-tuning and as an output. It went through the stages of evaluation. You will see we have a different versions. It's in process of further fine-tuning and building some different layers. I will say a few things about that at the end as well. So specifically to fine-tune these base models, we use the IPCC reports, Intergovernmental Panel for Climate Change. This is the body which organizing the COP conferences. And as a result of their work, there are a lot of reports, and many of these reports are consisting of huge number of pages. Specifically, this Climate Change 2022 synthetic report has 81 pages. And it is unlikely that someone who is not expert can read all these 81 pages just from these reports to find some relevant information. That's how Professor Brendan Mackay came up to idea not trained this large language model and use the front end as from generative AI and ask a question rather than for someone to read all these reports. And I will show you some samples. These reports are written in semi-scientific language, so and there's a lot of terms where normal people probably cannot understand it fully unless reading it carefully through. So in process of preparing all these reports for training the large language model, we built a lot of dedicated code to clean up the specific text. For example, CO2, you have a different font, but it's it was very important to capture all these. There's a lot of information inside the brackets which are relevant, which are pointing to the different tables or figures and everything. So that was first step to ensure. So this is the sample of this summary for policymakers, and you can see there is a lot of information. Some are relevant. So, for example, we removed from the, if it's inside the brackets referring to certain figures, that's obviously not relevant for train the model. However, these figures within the for example, on the first line was 1.09, in brackets 0.95 to 1.2. So we kept this information. And that basically resulted, after a lot of code, resulted that we prepared data for fine-tuning of a large language model. And we also structured, if you see the user input on the bottom, where we added the average annual GH emissions. So we formed the questions, because how the generative AI works, it's matching the your query in a high dimensional space with closest vector in a deep neural network to answer your question. So these are some more details. You can see that, for example, we did the fine-tuning in many steps. I found that it's much faster to fine-tune in multiple steps with a small amount of data rather than having at one 10 million lines of instructions. So, for example, here I highlighted in yellow down, there was 18,000 line, and that was specifically run on trained on 5 A100, and as a result, it came back with this model which has about 14 billion parameters, latest version of model. So I said that we went through the stages to creating DORIS, which is Digital Oracle for Research and Sciences. And as you can see, what I usually refer as a baby DORIS 1.0, but or current version is 3.04. And I see DORIS as, obviously DORIS because it's girl, Doris' name, as a smart, cute, nerdy, wizard-like girl, because she really likes, she really knows a lot, as I will show you in a minute. So let me just run this video. I asked Doris, who are you? She said, I will read this part in case you cannot read it, it's small. I'm artificial intelligence called Doris, developed by Professor Bela Stantic. I'm here to help answer your question and provide you with useful information. And then I said, thank you. I said, she's very polite. You are welcome. And for curiosity, I asked the question, who is Bela Stantic? And she answered, Professor Bela Stantic is a well-known computer scientist and engineer. He is the founder and CEO of Professor Bela Stantic Institute. That's not completely accurate. I am director of Big Data and Smart Analytics Lab, where Doris was developed. Prof. Stantic is renowned for his research in artificial intelligence, machine learning, and computer science. He has published numerous papers and articles in these fields and is a frequent speaker at international conferences. So why I'm saying, because Doris is also fine-tuned with the scientific papers. And I believe that she managed to get these details, or she concluded, because I was author on these papers on bias. So I noticed that Doris herself is evolving over the time with all this fine-tuning and becoming more and more intelligent. So a few days ago, I think on the 18th, I asked Doris, what do you know about IPCC reports? So she said that there are reports from Intergovernmental Panel of Climate Change, and what is most important, she said that its reports are widely regarded as the most comprehensive and authoritative source of scientific information on climate change. I also asked what type of reports do they have. So why Doris does not use the reinforcement learning to rewire neural networks, so you cannot influence like you can influence some other generative AIs which use the reinforcement learning. She remembers your conversation, so I don't need to ask. It's sufficient to ask what type of report do they have, and I believe she got it correctly by saying special report, synthesis report, methodology reports, and everything. So I asked some specific question, and on the top side, it's actually, I found it in instructions for training, and I even copied, actually I didn't, some part, but I added what will happen. And she answered with all these details, and that I looked into the actual report, and I believe they are correct. So I asked an interesting question. What is the average sea level rise since I even misspelled in? I noticed just now, but she's very smart. And since year 1900, and she replied, I looked into these reports, and this is the correct information. I asked ChatGPT-4, and they provided completely different. Before, I asked ChatGPT 3.5, which is completely out of correct information. Why it's out? Because these large language models, what ChatGPT relies, are trained on a lot of information, not just on the trusted information. And therefore, they cannot find the correct answer. If I tried now, and you can try that, this question, and ask, well, what is the average sea level rise since year 1900? And whatever ChatGPT say, just ask, are you sure? And probably it will say apology, and then it tells you something again. And if you ask again, are you sure? Then they will say something else, or will say, oh, go to this website or another website. And the reason is simply because there is a lot of contradicting information. The purpose of this Doris for the climate change is that she has information only from the trusted sources of data. I used this, I was keynote speaker at several conferences on climate change, including last week on impact. And I used to showcase, I asked, are there any unsustainable practices in one five-star hotel in Hong Kong? And Doris, I have Doris, which is trained for sustainable tourism, and one which is trained specifically fine-tuned with the reports from the climate change. You can see here on the top right-hand side that DORIS based and also on the TripAdvisor comments managed to find that there are some unsustainable because single-use plastic, over-reliance of artificial lighting. On the left-hand side, it's what I asked last year, ChatGPT 3.5, and top one, it's our baby DORIS 1.0. On the left-hand side, it's a ChatGPT 3.5, and you can see that ChatGPT 3.5 said, oh, why my cutoff is 2021, I don't have information, but if you want, you can go to the hotel website. Obviously not much of use if you want to get information. On the right-hand side, DORIS 3.0 2, therefore it's on the climate change, and it already have information that that hotel has received various certification attesting its commitment to sustainability. However, because of comments in TripAdvisor, still she's aware that there is some unsustainable practices with single-use plastic and waste management practices. I did ask a few days ago ChatGPT 4 as well, and you can see that they said that they couldn't say anything specific, but some general, provide some general insight into common unsustainable practices. So again, why I put this slide to showcase how it's important to have this fine-tuned model with the specific, relevant, trusted sources of information. What people think about DORIS, let me say about Professor Susan Becken, when I showcased DORIS to her, she said, impressive, amazing what is possible and what you have created. Another researcher said, I found DORIS is smarter than ChatGPT tool. I love DORIS more. So in conclusion, throughout my presentation, I highlighted the benefits of the approach to have the fine-tuned large language model, smaller base models, fine-tuned with the trusted information, where you can consolidate information specifically about climate change, in this case, as we fine-tuned, and we are continuing fine-tuning from IPCC reports. Thanks to these generative AI front ends, which eventually we plan to incorporate on the IPCC website. Professor Brendan Mackay is looking for option to have on the IPCC website chat where you can ask the question about their reports. And as I believe many of you, if you read these reports, they are written in a semi-scientific way. And secondly, there is thousands and thousands of pages. So you really need to be very committed and dig through to find specifically what you want. However, all this information is grounded on extended research of scientists, and it's extremely valuable. So being able to synthesize the knowledge from these reports by public in a form of chat as a generative AI is extremely valuable. In addition, by extending this large language model with the social media, it is also possible to extract the opinion of people. What actions do they do, what they don't, and it will be much easier to educate people to behave in a way to ensure that climate action is in place. There are still a lot of challenges if we are talking about this generative AI and large language model. There are issues with hallucination, which basically means that because your question is converted as a vector in high dimensional space, and then it looks for the closest vector in high dimensional space of this large language model. We, in relation to DORIS, I have a PhD student who is specifically looking to reduce the hallucination, and so we have some success, but it's still the extreme open research question. Another is bias, same as the other large language model and generative AI. I don't want to specify specific large language model, but I'm sure that you came across in media there was some of the generative AI accused because of different bias. We also at Griffith, I have a PhD student which is working with me on reducing bias of a large language model. And the big challenge is obviously wide acceptance of public to increase the awareness of availability, and also to increase the awareness about the accuracy of this and trustfulness of this system. So that would be all from me. I'm happy to answer any question. So thank you for your attention.
Yes, thank you, Bela, very much. Now we have plenty of time for questions. So if you have a question to ask Professor Stantic, please could you post it in the Q&A stream. Whilst we're waiting for people to think about their questions, Bela, could you just explain a bit more what you mean by hallucinations? You're saying that ChatGPT suffers from hallucinations.
Thank you. Not just ChatGPT, many other generative AI suffer of hallucination. As I said, because the question of what you are posing is converted as a vector in high dimensional space. It's matching what model has closest. That's why you can confuse it and say, are you sure? So if it is possible that you match something which is closest, but it's also relative how close it is. So if it's too far away, it is possible that you have something model is answering something which is completely nonsense or not relevant to your answer. That's why as well, if you ask this model, are you sure, it will return with another closest vector. But I noticed that they are improving. I will probably need to create some samples in the future as well about hallucination. For example, I was giving a talk recently at another conference which had industry experts, and they tried to experiment for building the itineraries and ask the question, for example, at what is the best flight to go, or what is the working hours? Yeah, what is the working hours? What he mentioned about one institution, and it came back that working hours are 12 to 12:30 or something like that. Because it was talking, probably model was trained and where maybe 12 to 12:30 are not working with customers, but and they couldn't find any other information. So those are the samples of hallucination, which come back with something which is completely not relevant. So what we are trying as part of PhD that one of my students is doing to measure this distance in high dimensional space. And I have one sample of where I intentionally tried to confuse Doris, and I couldn't. She came back and says, sorry, I don't have this information. However, I know this, and I got this information from this website or this data.
So Doris will give you an indication in the reply as to some assessment of the accuracy of what she's telling you?
Yes, if you ask what is the source of this information, she will specifically specify where from she get data.
Okay.
I think on the sample about I used, if I can scroll back, okay. Somewhere maybe I don't have in this example, but it says according to, you said according to estimates from the Intergovernmental Panel on Climate Change, IPCC, each additional ton of CO2 emitted could result in average temperature increase. So she's providing the source of information, so, which is very important. Or if she did not reply, in this case, I have some other samples where I ask what is the source of this information. I think I asked that for the what is the average sea level rise. Yeah, but here also she said that it's according to these reports. But sometimes when I ask, she says, sometimes not. But if I ask what is the source, then she say, even she can say from which report.
Again, plenty of time for questions. If people want to post a question, please just pop it in the question box. Or if you want to, there's a small number of us, so if you'd like to just turn on your video and mic and ask Bela a question directly, that's fine as well.
So am I still sharing the screen?
Yeah, no, we've stopped sharing now.
Okay. I apologize. I'm on my Mac and never did that on Mac, so it's a bit more.
Okay, I think Susan might have a question for you.
Not a question, but just thank you for the presentation. I'm just a little bit overwhelmed by the information, so I can't even concoct a question at this stage. But it's really great to see what's happening in the background of some of that work too, because what I can see is some fantastic opportunities in the future.
Yeah.
Thank you.
It is, if I may say, Brendan, it was Brendan's idea actually, and he gave a name to Doris. Originally, he wanted to call it Boris, Bela's Oracle, but I said, well, it's not just my work, it's whole group. And then he said, what about Doris? So thank you, Brendan. And Doris is becoming very famous all around the world. I just gave a talk at United Nations conference on tourism, and I introduced Doris for sustainable tourism. And the ministry from several countries like Doris so much.
Yeah. So there is a question from Patricia. Thank you, Professor Stantic. I was wondering what kind of mechanisms are in place to mitigate the risks of misinformation or bias in such a generative AI system?
Yeah, I think I briefly mentioned that when I said about challenges. Yeah. Hallucination and the bias, it's very important. But if you don't have a contradicting information in your data set, it's less likely that you will have a bias. But we are also working on, I said that I have one PhD student working on bias issues in these large language models. It's a big issue. I'm sure that you saw it in the news, some of these big generative AIs being sued for different reasons. One is also for bias.
Yeah.
But my view is, as I said, trusted information, not contradicting information, just relying on scientific facts, and then it's less likely that there is a bias. There are some concerns, what also we are addressing in a computer science, forgetting by fine-tuning. So if you have one fact and some new report, it's replacing the fact. They in last report it says that sea level rise 1.8 millimeters. Now they are in this year report, if they say it's 1.9 or 2.2 millimeters per year, then it's important to forget when fine-tuning or relate to the certain reports. Specifically, if you say, according to this report, what was the sea level rise? But there are the chances humans can reason, but for this generative AI, it's a bigger challenge because of not directly hallucination, but because of how likely is that your query, if you don't specify specific report, to ensure that it's capturing only the latest. And that's what we are also looking for getting by fine-tuning. So that is open research question as
well. Anything else there from our remaining visitors? There is a new post somewhere. Yeah, that's right. Patricia is saying that that's the power of combining cutting-edge AI with reliable climate data is no doubt another great tool in the fight against climate change. So I think we all saw, heard in the news that in the last week or so, following the latest Category 4 or 5 hurricane in the USA, how weather reporters were being abused because it was being claimed that they were making it up, and there was even social media posts saying that the rain, the radar for tracking the rain was causing the hurricanes to be worse. So this and actually Griffith is co-hosting with the UN a conference next month on disinformation in the Pacific. So this whole issue of disinformation is really a hot topic at the moment. And I think what Bela's trying to do with DORIS is at least trying to given that generative AI is rapidly becoming part of our everyday life, to be providing tools that enable people to access trusted information about climate, I think is going to become really critical in the years to come. So Bela, thank you very much for your presentation and your fantastic research. Thanks to everyone for joining us, and please look out for our next webinar in our Climate Action Beacon webinar series. Thank you.
Thank you, Brendan. It was a pleasure to give a talk. See you all.